In our first two lessons, we learned about meshes and shaders, and so those are very straightforward topics. And now today's lesson is titled Procedural Design. So what does that mean? Basically, if you have a hard-coded program, technically that program will be procedural because it's providing a set of steps or procedure for the computer to execute. But since that program is not configurable or dynamic in some way, it's not really taking advantage of the fact that it's procedural. And so let's cross this out. We don't want this to be hard-coded. And let's look at the example of our quad from lesson 1. Okay, we hard-coded the vertex buffer, first of all. We specified all the different points, and they kind of range from 0, 0 to 1, 1. And then we took the indices of those points, which were 0, 1, 2, and 3, and we used those to connect the dots and create the index buffer of the mesh in a hard-coded way as well. So that worked pretty well for learning how meshes work. But as we move forward in this course, we want to do something that has more of a procedural design. So in this lesson, what I want to do is take our quad that we drew there and turn it into a grid. We'll be able to specify in our grid how many rows and how many columns that we want. And with those sort of parameters that we're giving our algorithm, it will be able to generate any number of potential mesh outputs. And so even our quad that we did in the first lesson, you could think of that as being a 2x2 grid. So we'll still be able to create that quad with our new algorithm, but it will be configurable or dynamic. So we could create all different kinds of things like this 4x4 grid that I just drew. And we could say that to start with, we'll use the exact same sort of bounds or shape that our quad had in the first lesson. And so because of that, you may be asking, well, if it's the same exact shape, what's actually the point of doing it with more vertices in this kind of grid-like pattern? Why not just use the hard-coded mesh? And that's actually a really good question. Now, one kind of silly reason, but it is valid, it's true, is that it's just kind of fun to have some procedural toy we can play with and get different results from the same code. But this is really just the very beginning of how we'll use this concept of procedural design as this course goes on. And actually, we'll make specific use of this grid that we're making today. I think you'll see even by the end of the next lesson just how powerful this grid-like construction can be. So that's kind of our game plan for today's lesson. Now, before we just dive in and start coding this up, let's actually look at what I just did as I drew this and start sketching out a pseudocode or natural language grid construction algorithm based on what I just did as I drew that. Okay, so we'll use the idea of iteration or loops here. And as you saw as I drew this, I kind of went row by row from the bottom up. So our algorithm can start by saying for each row, we'll do something. All right, so that will kind of iterate over all of our rows. And we maybe want to say up here, we want to have like an n rows defined and an n columns defined as our sort of ways that we can configure this, right? So for each row, and I don't know why I added an S here, let's delete that. So then as I iterated over the rows, I then stepped through column by column within that row. Okay, so we can put another loop inside of this outer loop. And so we're going to have a nested loop. If you've used, nested loops before, that should kind of make sense to you. If not, hopefully it still makes sense. But you can always ask questions in the comment section, and I will be watching that. So if you're confused about something, or if I didn't do a great job of explaining it, that's the place to ask your questions. But anyway, so as I was stepping through those rows column by column, I was then drawing a point at the intersection of the row and the column. So for each sort of combination of rows and columns, there's going to be one point that's drawn. Okay, then the last thing I did was that if there was sort of a new quad available for me to create triangles on, I then connected the dots, only if I could. Okay, so then I'll create like an if statement here. I'll say like if new quad, then I connected the dots. Okay, and then maybe I'll just add some sort of vertical lines here so you can see what are the levels of indentation. These two kind of happen both within this sort of intersection of the row and column. We would draw a point and we'd also check if there's a new quad. And then if there is a new quad, then we sort of go a further level into the algorithm and connect the dots. Okay, so we've got sort of our algorithm sketched out that we want to follow here. So now maybe as our last step on the whiteboard here, let's just kind of take this for a test drive just to make sure that it actually works. So we can use a grid construction that's a little bit different. Let's use something kind of simple. And maybe we can even use a different number of rows and columns just for fun to see if it works there. So we'll say, let's use 3 columns and 2 rows. So it will have 2 rows like this, but an extra point in the middle. So we'll say for each row, so we'll start at our first row, and then for each column, so let's start stepping through the columns, we have 3. So I'll draw a point. Is there a new quad available? No, we only have 1 point. So let's go to the next column, draw a point. Okay, is there a new quad available? No. Let's step forward again, draw another point. Obviously no new quad available. Okay, we're done with this row. Now let's go to the next row, and we'll start at the first column. So we'll draw a point here. Is there a new quad available? No. Now we could create a new triangle, but we don't have a new quad available yet. So we'll skip this, go over to the next column. We'll draw our point. Is there a new quad available? Yes. So now we will connect these dots, and that means that we're going to create 2 new triangles. Okay. Now we'll step to the next column, draw our point. There's another quad available, and I'll just draw like another line here just to show you, right? We're creating a whole other triangle using this edge here. And then we'll also create a triangle here. Okay, so hopefully you have an understanding at this level of what we want to do. Now, as we actually translate this to code, we're going to have to be more specific. What exactly does it mean to draw a point? What does it mean to connect the dots? What does it mean if we have a new quad? But let's kind of use this guide as we're going through and creating our procedural grid. Okay, so I've set up a grid scene for us to work in here, and there's already a grid in here. What's going on? Did we finish the lesson already? No, this is still a quad, but I've taken our test shader and I've just kind of reverted it to that point where we're using the input position. Remember, this ranges from 0 to 1, and we kind of hacked that because we did not build our mesh with texture coordinates. That way we could get a texture rendering on what's now the quad. It will be our grid. But because of the fact that this looks like a grid already, this is kind of confusing. Let's use a different texture on this. So let's use this sort of gradient, and let's just get rid of the tiling. And you'll see kind of at the end of the lesson why I want to have a texture on this. But let's now take this quad, let's rename this grid, and get rid of this quad script on here. So our mesh is still set up here, which is why this didn't disappear. But when we create our grid script and build the mesh from that, then it should override this mesh. And so let's do that now. And we'll call this not grid, we'll call it PFX grid. There's already a component in Unity that does something or other called grid. So we'll call this PFX grid. Okay, so let's open up our grid script. And to start off, let's just take our quad and copy that over to our grid script. And then we'll just make sure this is still called PFX grid. This way we'll get some of this build mesh sort of boilerplate stuff in place. Now here where we assign these arrays to our mesh vertices and triangles, we're going to want to change that. So for that, let's use lists. Let's bring in our system.collections.generic namespace. That will allow us to create lists. So we can create one list of vector 3s for our vertices, and we'll create a list of integers for our indices or triangles. All right, and then we'll do something in here where we'll step through our algorithm and fill these lists in with values. And then here at the bottom of this build mesh method, we'll then take those lists, which will be populated with data, and we can say verts.toArray. We'll kind of convert our list to an array and assign it to our mesh vertices. We can do the same thing here, take our ins to array. And actually we can take this mesh and just move it down to the bottom of this method as well, because we're not really going to use this, right, until these lists are kind of ready to go. All right, and the reason that we're using lists is that if you look at what we did in the whiteboard with our algorithm, and let's go split screen with that. As we iterate through our algorithm, we're going to be adding new vertices and adding new triangles. And so lists allow us to add as we go to that collection. And so I think it's a good match for the design of our algorithm. Okay, so now let's get started with the algorithm. This is our first step. So let's start iterating over our rows. And so we can do that with a for loop. So we can say int row equals 0. Row is less than our number of rows. Row plus plus. And then we can do the same with columns. And now obviously, right, we're getting complaints here. We don't have n rows and n columns defined. So let's define those. we can just make these fields that we can assign to from the inspector. Now, if you have not seen for loops before, just quickly, I'll explain what this does. We'll initialize an iterator variable. Here we'll call it column, and we'll start at 0. We'll use 0-based indexing. Now, this third part of this will say at the end of the body of this loop, we will increment this column variable by 1. That's what this ++ means. And then this declaration in the middle says that we'll continue through the loop so long as our column is less than the number of columns. Okay? As soon as this condition is not met, we'll break out of the loop. If we look back at the whiteboard now and look at our example, right, where we have 3 columns, we'll go 0, 1, 2, and then we'll break out of the loop because we'll have reached 3, which is the number of columns, and we'll be equal to that. We'll no longer be less than, and so we'll break out of the loop, okay? And maybe I'll give our code a little bit more space here so we don't get that line wrapping. And so now we've got these 2 steps of our algorithm complete. Okay, so now the next step of our algorithm is to draw a point. And as we saw in our first lesson, that corresponds to creating a vertex and putting it into the vertex buffer. Now, in our first lesson, we just used this sort of explicit declaration using literal values here. So we'll have to do something dynamically, right? And figure out what is our position that we want to create to put into this vertex buffer. And again, we're using vector 3s here. This is what Unity wants for our mesh data, but we just put 0 into the z coordinate, and we really just care about x and y. All right. And so here, x and y, it's going to be pretty straightforward. Our x value will just be dictated by what column we're on, and our y value will be dictated by which row we're on. And we also know that we want our range of values to go from 0 to 1 on each axis, okay? So what we can do is we can say, like, for example, our x value, we can say this is going to be our column divided by sort of the maximum value that this column can have, which is going to be our number of columns minus 1.0f. And by using minus 1.0f here, this will make sure that we're using float division, which will give us a floating point value as a result. So we won't just get either 0 or 1, we'll get fractional values between 0 and 1. And then we can do the same thing for our y coordinate, except we'll just use row here and number of rows, minus 1. All right, so those are our x and y values. And so now we've got our vertex ready to go. We can just say verts.add a new vector 3, x, y, 0. And so before we move on to the next step of the algorithm, let's just test this out and make sure that it actually is doing what we think it does. So let's look at the example that we manually built. We've got 3 columns. 3 minus 1 will give us 2. So we'll be dividing by 2. And so we can take our first column, which will be 0. 0 divided by 2, well, that's just going to be 0. All right, that's kind of obvious. 1 divided by 2 will give us 0.5, which that looks right. And then 2 divided by 2 will be 1. And let's just double check that on our 4x4 grid. 4 minus 1 will be 3 as the value we're dividing by. So obviously first 0, then 1/3, 2/3, and then 3/3, 100%. So I think we've got our vertex assigned correctly, and we can move on to the next step of the algorithm. So this conditional statement, if new quad, how are we going to determine if we have a new quad available for us to connect the dots on? Let's just think about what we did as we stepped through this manually. So on our first row, we were not able to create any quads. And that kind of makes sense because we're just making a line. And in order to make a quad, we kind of need to have 2 different dimensions available to us. So as we're on our first row, we can't do it. On the second row, we were able to do it, but we had to sort of step 1 column into that before we could do it. And that's going to be the case if we add a third row here, right? So if we add a third point, we could create a triangle, but we can't create the quad until we actually go 1 column in. Okay, so we can just say that our condition here, if new quad, we can say can add quad will be equal to whether our row is not equal to 0, our first row, and our column is not equal to 0, our sort of first column. So basically on either one of these axes, if we're on the sort of outer edge, we're not going to be able to create a quad, but otherwise we can create a quad. So now let's create an if statement. And here we're going to get to this tricky part of this algorithm, which is where we have to create our triangles and connect the dots. Now again, when we did this in the hard-coded way, it was a little bit easier because we could use these literal values, right? If you look at back here, we use these literal integers here, and I'll sort of trace this on the whiteboard. We went 0, 1, 3, and then we went 1, 2, 3. And so we're going to want to create this same exact pattern that we used on our original quad, but we're going to do it for each one of these little quads that's part of the grid. And we can't refer to their literal indices. We have to use like a variable, like we did with our x and y here, and assign the values to them in a dynamic way. Okay, so to figure this out, let's come over to the whiteboard and we'll recreate this quad, but we'll do it with variable names rather than the literal numbers that we want to connect. So let's paste this over here. And now we got this kind of as a blank slate that we can start adding variable names to this. And now as we're iterating through our rows and columns, remember here we created this quad sort of with this point as our current point frame of reference. And then we did the same thing for this quad. We were on the upper right corner as our current points index. And so we'll do this whole operation from the POV essentially of this upper right corner. And so as far as variable names go, we can call that our current point. And let me just give myself some more room here to write these variable names. And then the other points that we have as part of this quad we want to connect up, this will be our previous point that we just visited. So we can call that previous point or P point. And then we want to connect the point that's kind of immediately below us. So we'll call this point below. And then the last point in our quad will be kind of the P point below, the previous point below. So then we can just kind of copy paste that. I don't really want to write that again. We can just move this up, right? Now it's a capital letter, magically. And this will be our P point below. So that's kind of how we can think about the names of these points with respect to our current point that we're iterating over as we're building this mesh. And again, there'll be different integer values assigned to each of these variables, kind of depending on where we are in our grid. But we'll use these names in order to know which points we want to connect to which points. So let's come back to our code now. We don't really know yet what values go into these, so we can just kind of create variables and we'll say we'll do something with this eventually, so we can just assign default to that. I think is a good way of kind of saying that. So let's now use these variable names to create our triangulation pattern, and then as our final step, we'll actually figure out what these values will be. So if we want to use this same pattern, right, 0, 1, 3, 1, 2, 3, that's going to translate to P point below, P point, point below. So let's do that. We'll say ins.add P point below, and do the same with our P point. And then we want to go to point below. Okay, and then our second triangle is going to start at P point, and then we'll move to the current point, which we have not visited yet, and then we'll go to point below. And now we've got both of our triangles. Now we just need to figure out these values here. Let's just start with our current point. This is going to be the index of the point that we're sort of actively iterating over here. And so here where we're creating these indices inside of this conditional statement, we've already added the vertex that we're interested in to this vertex list. So the index of the current point is going to be the same as the sort of last point in that list, its index. So we just need the final element's index. And remember, we're using zero-based indexing. So we can just take this vertex list dot count and subtract 1. Okay, so we've got our current point. So then our previous point is just going to be our current point minus 1. So we can just say current point minus 1 here. And you may be worried, what if this goes out of bounds? Well, we're already kind of checking that with this can add quad condition. Okay, now our point below, that's going to be one row below the current point. And if you look at the structure of these rows, that's just going to be our current point minus the number of points in each row, right? So if we subtract off 1, 2, 3, 4 in this 4x4 grid, we'll get the point that's directly below our current point, if this is our current point. And the same thing will happen, right, in this grid where we have 3 points per row, subtract 1, 2, 3, and the number of points in each row is just our number of columns. So we can take our current point minus our number of columns for our point below, and then this p point below is just going to be this value minus 1. All right, so I think now we've got our entire algorithm coded up here. And now there's one final thing I want to do before we test this out. I kind of withheld this information until now, just to kind of make this as simple as I could. I also want to give this a width and a height. And so we can say that the size of this won't just be from 0 to 1. We can kind of scale our x and y axes independently. So we can just take our y here and multiply in our height, do the same with x, multiply in our width. And so that was pretty easy, but we now have an additional way that we can configure our procedural mesh and make it more dynamic. Okay, so now let's go back and test this out. And let's take our grid object, which currently has no script on it, and we can add our PFX grid. And let's just move this to the top. And so let's make this sort of the same as the mesh that's currently on it, and let's see if we can detect any differences. So we'll make our number of rows and columns 2 and our width and height 1, and let's build this. And we're not seeing any differences. Now, are we sure this is actually working? So let's now increase our number of rows and columns to 8, let's say, build a mesh. And now we've got, this is pretty exciting. We've got a procedural mesh that's actually taking advantage of the fact that it's procedural, right? And we can up this to 16 by 16, and we could really make this really huge, 256, let's see. So that is like creating these tiny little triangles, but it's doing this all with the same exact code that we just used to create our single quad mesh. So now let's start playing with our width and height. So we can make this width, let's say 4, and let's see what that does. So it would be kind of wider than it is tall. And so that worked, but now we're seeing 4 copies of our texture. So if we do what we did in the last lesson, and I'll open up that shader again, where we used our object space position to sample from our texture, what's going to happen is if we have positions that don't range from 0 to 1, we're going to start sort of wrapping over and start copying that image over and over again. Now, maybe that is what you're looking for, or maybe like in our first lesson, right, you just know for a fact the mesh that you're using for some special effect, let's say, does have this particular object space position to it, and we can save a little memory or whatever by reusing our object space position for this purpose. That's totally valid. But for this example, I kind of want to see what this looks like with the gradient stretched across the whole mesh. So let's give this a set of texture coordinates so that we can keep this shape and have it go from 0 to 4 in the position, but we'll have it still go from 0 to 1 in the texture coordinates. So let's open up our grid script here. And what we need to do is just create a separate list here. And we'll make this a list of vector2 texture coordinates. And basically for every vertex that we add, we just need to add a texture coordinate that will correspond to that vertex. And we can scroll down here, and where we're assigning these to the mesh, we'll also assign our texture coordinates to UV, like we saw in the last lesson. And so these are vector 2s that we're assigning to something that's sort of by convention called UV. And so we can think of our first component of the vector 2 as being called U, and our second component being called V. So now let's think about what our U and V coordinates will be. And we really just want this line to be our V coordinate, right? Before we apply this height to our Y, we really want to say this is our V. And then we can say that our Y will be our V times height. And then we can do the same here. We want this to be our U, not X. We want our X to be U times width. Okay, and then here where we add our vertex position, we'll also add, I would call this the vertexes texture coordinate. Unity uses a slightly different terminology where the vertices are the actual positions. I would call those positions, but whatever. And then this will be UV in our vector 2. And so let's try that out. And we'll build mesh. And we're not seeing any change because we're still using this custom shader. So we can just come in here and kind of just make this back to the way it came, fresh out of the box. We can use our UV coordinate to sample our texture. come over here, and hey, now we've got our gradient stretched across our whole grid mesh. All right, so that's it for this lesson. And I hope you enjoyed this project where we made the procedural grid. I do think it's kind of satisfying to just change this around and see what happens and see a different result coming out of this script. Now, again, though, this is just the same shape, though. No matter how we configure this, we're not changing the shape. And so I think in the next lesson, you're going to see just how powerful what we already made, this procedural grid, really is. We'll be making a couple really different shapes in the next lesson where we learn about 3D modeling, and our procedural grid is going to play a key role in that. So I'll see you in the next lesson.